And what we're going to do is kind of go over layout. By now you should have viewed the bandsaw video. And what you're going to need for this job is 2 of these pieces, 1.5 inch thick, 2 inches long, 1.5 inches wide. I've already blued this up. And if you remember, and those of you that haven't been here, the bluing station is back there along the wall. Paint up your part, give it about 5 or 10 minutes to dry, and that'll make it ready for this stage, which is called layout. You remember the secret to precision parts? What's the main secret that I said for precision part? Everything's got to be clean, right? So this is an inspection stone. It's a precision piece of equipment. It's not a work table. We don't pound things on it with a hammer. We don't wrench on it with tools. It's a super flat surface that will give you perfect results if you needed it to be, because you need a flat surface when you're measuring and laying out parts and inspecting parts. Everything comes from a theoretical flat plane. And in GD&T you're going to learn what a datum reference simulator is, and that is this. This reference is a datum from another part. But looking at the drawing, again, you should be have saw cut 2 of these because you have 2 components for this assignment, and you should have filed it per the assignment. So you're going to file the top surface flat. You're going to file one edge and another edge perpendicular to each other, basically, with a hand file. And you're going to remember those 3 surfaces because you're going to need to use them now. So let's just look at the part real quick. If you take a look at the part, and let me make sure this is zoomed in good. Yeah, okay. If you take a look at the part, it is showing us that you want to be a hole, you want to place a hole right in the center of the part. So the drawing shows the part is 2 inches long, 1.5 inches high, 1.5 inches thick, and it's showing the center line of this hole down from this top surface is 0.75, so it's 3/4 of an inch, and it's over from this edge here 1 inch. So at the intersection of these 2 lines there is a center point for this hole. Now if you kind of look at this and say, all right, if I were to show a corner or an edge where all the surfaces come from, where all the dimensions come from, if you look at this right edge here, it shows the overall dimension and then it shows another dimension to the center line. So this edge right here, if I'm holding the part up in front of it, this edge is what we call a reference surface because all the dimensions are coming from this edge, and you'll see that in most drawings. A common corner where all dimensions come from. That's called a datum. So you'll also notice the top edge of the part. The location of this center line comes down from the top. We don't care what this distance is so much, but we do care that this distance is within plus or minus 1/64 of an inch. So now instinctively, if you were doing this in at home and all you had was a ruler and a pencil maybe, you would then say, okay, take your ruler, you'd put it on the edge here and you'd measure over 1 inch and you'd put a little pencil mark, right? And then you'd measure down from the top edge 3/4 of an inch and you'd put a little pencil mark, then you'd see where those little marks cross, and that is your intersection point. So the first thing I want to do is say, we're basically going to do the same thing, but we're going to use precision layout equipment for this, all right? So what we have here is, you're going to want to get yourself a tool for scribing. We actually have one in here. This is sort of a combination scribe and what we call a prick punch. First thing you want to do, this upper right-hand corner here is where the 2 datums intersect, right? This top is our datum and this is our datum. So this corner is our datum. So I'm going to mark that on here just with a little X right in front of it. Okay? So if we put this part up in front of our drawing, all our dimensions come down from the top, over from this edge. So that means where these two planes intersect, that's our datum corner, our datum, if you will. So I put a little X there because what we do now is we are going to use our precision layout equipment here to mark the 1.5 inches. Rather than take a ruler and measure here, we're going to take this ruler, gauge it off of this surface. Part is going to be placed like so against an angle plate. It's going to be held, and then we're going to scribe. So the way this thing works, let me get myself zoomed in. I'm zoomed in pretty good. Yep. The way this thing works is this value here that you're reading is a distance that it is off the top surface. So the first thing you need to do is you need to calibrate the instrument to the surface. So that goes down, and again, what we want to do is we want to make sure it's absolutely clean. And then underneath this, it should be clean, because if you don't have any particles underneath it, you'll get a clean. If you have chips under there, it's going to be sitting like that. I mean, we're exaggerating, but you will not be precise. So we've got everything clean and brushed. So what I do is I just take this gauge and I'm going to bring it down just till it lightly touches the surface. Okay, you see it's sort of at 0 right there. So what I'm going to do is I'm going to adjust it a little bit. So now, when this part is just touching that surface, it's 0. And you reset these. These are movements here. So what we want to do now is our first part, all right, our reference edge. That's this top surface. The top surface goes onto the plate. All right, so get this down a little bit. So notice our X is facing down. It's on the plate. So we're sitting like this. It's upside down with our plate right here. And because our dimension is coming up from this surface, it's got to be set to 0.75 of an inch. So we take this and we move it till it goes, so there, each rotation of this is 0.1 of an inch. So I've just moved up 100 thousandths, 200 thousandths, 3, 4, 5. How many 100 thousandths are 3/4 of an inch?
7.
7. So I got 5, 6, 7, and now we need an additional 50 thousandths. So each line on the dial is 1 thousandth. So there's 10, 20, 30, 40, 50 right there. So we now lock this in, little lever. This distance, if we were to measure it now, is exactly 3/4 of an inch up. So now it's a matter of taking this, let me make sure that's in frame. We're going to hold it, and then we just kind of put it there and just one shot, drag it across, and you'll see that we've made a scribe. I know this is my datum edge. I know I'm exactly 3/4 of an inch. I might want to check that. So what we could do is just take a caliper. I'll just open it up by eye to 750. And you'll see that we're pretty much right on the money there. Right? Take a precision rule, a steel ruler, and measure that. So now logically, we've got this edge, so we got to mark off this 1 inch here. So that means that my datum surface, the X is there, has to be on this plate, and we're going to go up to 1 inch. So there's my datum surface. It rotates like so. I'm going to adjust our, it's called a height gauge. First I'm going to unlock it. We're at 750. There's 800, 900, and there is now 1 inch, and you'll see the dials turning right there. Exactly 1 inch up. So what do you think we're going to do now? Strike the next line, hold it with our finger, One and done. Don't go back and forth like some pencil. If you go back and forth, you're going to miss it. It's going to separate, you know, you'll have a lot of scribes. So you want to do it one shot. You can also do this with a steel rule. We demonstrated that the other day when we were working on laying out our lathe part, right? We took our slide here. I mark it off 1 inch. I could have gone like this and put the 1 inch mark like so, use a scribe and scratch it. Then I can mark this thing at 3/4 of an inch, put it on here and scratch it. Much more accurate to do it that way and a whole lot easier if you ask me. So, so we now have a layout and we're done. All right. So the next step will be to plan how we machine this, and we'll pick that up in just a minute. Let me turn this off, and now we're going